It does turn out that if you set y or f of x or whatever function notation you like equal to a radical expression, it'll be a function. It'll pass the vertical line test. So let's go ahead and evaluate the function f of x equals the square root of x minus 1, if we can. So in part A, I ask you to find f of negative 2 and f of 5. So do you remember what the function notation means? What does f of negative 2 mean? Plug in negative 2 for x, but what happens if I plug in negative 2 where that x was right there? I end up taking the square root of what? Negative 3. Is that something we can do right now? No, not right now. Undefined. Right? For now, we can't take the square root of a negative number, so negative 2 is not in the domain of f. Remember, the domain of a function is a set of all values we're allowed to plug in to the function. Negative 2 is not one of those. Okay? So well, actually, the second part of this problem, f of 5, is that something we can plug in? Yeah. So f of 5 is equal to what? Square root of 4. Yeah, 5 minus 1. Square root of 4, what's that? 2. Do we need absolute values around the 2? No, because the absolute value of 2 is 2. We know that. Okay. Let's graph that function. If you're not graphing it using a calculator, you're going to want to plug in convenient values of x. So what do I mean by convenient values of x? Well, how about perfect stuff? X values that you end up getting perfect squares underneath the radical. Do you understand what I mean by a perfect square? Sure you do, because we talked about the difference of two squares formula, right? So what are the perfect squares? There's 1, 4, 9, 16, 25, 36, on up through 12 squared. You should know, right? 12 squared is 144. Those are the perfect squares. So if let's make a t-chart. Well, the y is f of x, right? So y is f of x, which is given by the formula square root of x minus 1. Remember, you can always replace y with the formula, f of x, assuming it's given as a formula. So what are your convenient values of x? What's the lowest one you can plug in? I heard a 1. Yeah, I don't think there's any problem plugging in a 1. Because when you plug in a 1, you get the square root of 1 minus 1, right? Which is square root of 0. What's the square root of 0? 0. So no problem. But if you try to plug in something less than 1, if you tried to plug in 0, you'd end up taking the square root of negative 1, which is not a real number. So you wouldn't do that. 1 is the lowest x value we can plug in. What's the next convenient one? That'll give us a square root of a perfect square. Well, that will be convenient, but it's not the next one. 2. Because the square root of, okay, you plug in 2 for x, 2 minus 1 is the square root of 1, which is 1. So 2 goes with 1. And then 5, we already know 5 goes with what? That's the one we evaluated up here, right? We got 2. That might be enough to get a decent graph right there. Let's see. You want to do 10? So if you plug in 10, you get the square root of 9, which is 3. Sure. Okay, so now we have probably more than enough. Let's graph it. We're going by ones on each axis, x versus y. 1, 0 is right here. 2, 1. And 5, 2. 1, 2, 3, 4, 5, up 2. So you can see that you don't want to connect these points in a straight line, do you? It's a little gentle curve. Like that. And it keeps going, right? Now, could you identify the domain of this function just by looking at the graph? Think left and right. What would the domain be? In interval notation, what's the smallest x can ever get to on the left? 1, right? Oh, and that's what we saw. Oh, yeah, x equals 1 was the smallest value we could plug in for x. That makes sense. So the domain starts at 1, including 1, so bracket, and then how far does it appear to go? To the right? To infinity. So the domain goes from 1 to infinity. It's been a while since you had to read the graph to get the domain, but does that jog your memory a little bit? How low does it get? How high does it get? That's the range, right? How low does it get? So think, okay, this point's the lowest point. How high is it second coordinate-wise? How high is this point? If it's on the x-axis, 0. And then does it appear to keep rising as you go that way? So 0 to infinity. So the bracket means the 0 is included. The parenthesis means you never get to infinity, right? Okay.